Okay. So today we'll be seeing how we write stored procedures when we don't get input in the form of file. So today we'll just have an overview on only the database part. Tomorrow we'll have IIB section separately. Now I'll just tell you how this CDC pattern works. Like this is our database. 1 minute. Okay. So now we are currently in dev database. So we have separate schema for our control table, for our RDS table, and for our audit framework, which we were telling yesterday. We were talking about the message log framework, right? For everything, the data will be logged into each separate table. So in the CDC pattern, what will come into my picture is there will be multiple source tables, whereas even we will not have access to the mainframe actual tables, and that tables it will be replicated to the RDS table via OGT. OGT is the one which we will not come into picture, but that each and every single tables will be replicated to our RDS table. When I say RDS table, it is it's a kind of EDIS user schema where we can have access to those tables. So the CDC pattern, how it works like, whenever there is a change in the mainframe tables there, that will be whatever the changes, this OGT will capture and that will be replicated into my RDS table. So each and every business object will have its own control table and a set of RDS table. For a simple board, it might be of 2 or 3 tables, and you can have also 10 tables around it. With the help of those many tables, you'll be generating a stored procedure. Now let me show you how a control table looks like and for how every board we have. RDS control is the schema where you will find each and every, for every board, there will be one single control table. So these are the control table, whatever you are seeing, these are for separate boards. So let me take one example. Okay, this is one control table. This is how it looks like. So here, if you see the structure of the control table, this will be not the same for every board. The columns which I'm just highlighting, corp, division, and facility. For this particular warehouse master board, we have these 3 key columns. Whereas in case of other boards, you will have a set of unique key values which is specific to that board only. But this column, whatever you are seeing, the process indicator, insert minute, and this source code, all these columns are common, and for every board you will have this in common. Only these will be getting changed. So what how the process goes is, so we have a control table here, and all these records will be inserted by, we have 2 kind of, two approaches I can say. We have how this records get inserted. One will be OGT will be able to directly insert all these records here. And the other thing is we will have to write a stored procedure where OGT will not be doing. We have a separate stored procedure where we will have a SQL query listed in our mapping document. With that mapping SQL, we'll have to generate a stored procedure which will go and hit my tables. That tables, it depends on the requirement. Sometimes there will be only, there is a requirement, there will be a requirement where only the updates of only 2 tables needs to be taken. So I will have only that 2 tables joined together where I will go and check for the changes. If there are any changes, I'll be inserting it here. So there are 2 approaches. So before you start this thing, you need to make sure like what is the approach, if OGT is gonna insert into control table, or we do have to create a separate stored procedure for it. So okay, let's see the 2 types now. First one, I'll take this warehouse master. OGT will not be inserting into my control table. I have a dedicated stored procedure for it, which will go and check for the updates. So how this works is, assume like we have got all these records into my control table. Whenever the records get inserted into my control table, here you are seeing the indicator as P. But in the initial time, the record indicator will be N, which means N for a new record. So every year, assume there are 100 records that you have that got inserted into your control table, and the next thing is you need to update that. You need to get that and process it into a raw data set. So for that, what you will do is this insert procedure, store procedure will be the first one, and the next procedure is you wanted to take that and you will mark it as X, which means we are going to process that. So that will be my next store procedure. We have a separate store procedure which will convert all the end records. Just you will find out the end records having the indicator as N, and you will just mark it as X, which means you are yet to process that. And the other store procedure, what it will do is, it will go, say if I'm telling only for 500 records, say if there are huge number of records, that in that case, we will not be able to process all the records at once. So what we do is, based on the volume of the interface, we define the particular limit. Say if it is a medium based volume based interfaces, we will have the row count as 200. So how much ever, if you get 1000 records at once, every 200 records in a batch will be processing it. Once you process the records, that X will be changed into P. As you can see, all these, since it is every records are processed, this indicator is changed to P. So this is how the flow goes like. Let me take the store procedures. Stop me if any doubts you have in middle.
Yeah, Shaila, there is one small doubt. Like whenever I will receive some new data, so it will append in this particular table only, or it will like remove it and new details will be filled in.
Can you repeat your question? I didn't get that. Sorry.
Okay, see, like I'm getting new data. Okay, I identify that I'm about to get new data. So
Okay.
from there, it will be appended in this particular table, or wherever you are like in the existing data, it will append it below, like in the below rows, or it will remove the existing data and will replace it by the new data.
Yeah, I got it. So the data will not be appended here. Instead, for every single record you have an update that will be inserted here as a new record. The existing one will not be deleted. That is what your question is. If any new update comes, it will be overridden, or yeah, it will be a new record. It will not override the existing one. Okay.
What she's asking, so these exist the records which now you are showing up, right? And then there is a new update. Will they stay, or like will the be, or this table will be truncated and then the new
No,
data
no.
will be loaded?
Whole table is a permanent table. We don't delete the records from here.
Okay, okay.
So how we have the control table for each and every single board, we also have store procedure for it. So this particular this board for which I have chosen here is, we have a separate insert store procedure, which means OGG will not be inserting my records into control table. We should write a SQL for it and then insert into it. Need not worry about this SQL part, because this SQL part will be given by the data mappers in the mapping document. Our duty is to just take it and convert it into a stored procedure. So here, how this works is, this insert stored procedure works is, we also have a separate other table called BO process control table. The first one where all the records which I showed, this one is BO control table, and only for this insert stored procedure, we have another table called BO process control table, for which you will have an entry for every single board. Somebody asked a question yesterday that, say if the same what is that, if new records are coming, how that will be identified. So that will come into picture here. So what we do is, before we start our searching for the new updates, what we will do is, we will store the current timestamp in a variable, and then insert into my VO control table based on these conditions. Here for this specific board, the condition is to take the delete records, update records, insert records. So that will be fetched here. How they are checking is, for every single join statement, you can see this this last line and comment. Here we are checking the last update timestamp column, which is greater than the timestamp in VO process control table. So in my VO process control table, if I'm gonna start a fresh bot, I will have, say for example, this warehouse master, I'm starting it for the very first time. I will have an entry in my VO process control table. That entry will have the bot name, and that entry will have a timestamp. Say if now the time is 10:45, now the next run for every 15 minutes we'll be going and checking for the updates. So for the next 15 minutes, 10:45 to 11 o'clock, there will be, assume there are 100 records. So that timestamp will be stored 10:45, and for the next run, it will go and search if any records are greater than 10:45. So you will get those 100 records here, and for the next run, you will not get the old record getting repeated here, because whatever the timestamp you are taking it, you are storing it here in this variable. Here, whatever the timestamp you are storing it in the variable, that will be only the old record. So for the next run, you will be getting only the new records. There is no in middle, nowhere we'll get the old records again. So that is the reason we have a separate table storing the timestamp for it, so that you will not pick the same set of records for the next run. So that is how happens in insert store procedure. And the next store procedure is the update one. Okay, before that, I'll just tell you this. This is the thing I was telling, that store procedure will be updating the timestamp. While updating the timestamp, this is the variable where we stored our current timestamp. So why we don't do directly the current timestamp is, during my insertion process, there will be some record. In a millisecond, I may miss out some records. So earlier we had this current timestamp here directly. So in a fraction of second, some records were getting missed out. So what we did is, before starting this checking for my updates, so we stored that in a particular variable, that current timestamp. So we'll update, so that we'll not in the middle where we check the records, whenever a new records get triggered, that records will not be getting missed out when we do this. So that is why we are using that current timestamp value here, and you will update the VO process control table value. So this is how my insert store procedure works. And the next store procedure is update store procedure. So here, as I told you, that all the end records will be changed into X. So this is just a variable where you are storing n X value. So you are updating the VO control table. You are checking if the value is n, then you make it to value as X. So this is how, I think most of you are familiar with SQL and PLSQL. So I think all these should be understandable. And even if you are not, that is not an issue, because this is going to be the same template that is followed throughout for all the interfaces. Only thing is that the logic, it depends on each and every, that will be specific to bot. The rest of the it is going to be a common template. So here you are going to update the VO control table where all the records are n, that you are going to make it as X. Only for this extract store procedure, when you are going to process it, all the records will not be processed at once. This is where my batch count will come into picture. So here it is not an issue, just you are just changing the n to X. So that will not be any, since we are not processing it, there will not be any kind of performance issue here. So since we are going to process, we are going to convert all the columns available in the tables into the XML, it will take some time. So we no need to go and change the entire records at once. So in every single batch, we'll be making this. So this extract store procedure, what it does is, here you can see these many columns. You may have how much ever tables for your bot, everything, this SQL part, whatever you were given in mapping document, you need to put all those here. For the fields which you have mapping, you need to put it here. So this, 1 minute. This DBMS XML generator, this is the function where all the SQL data, the raw SQL data will be converted into my XML, so that my IID will understand the XML and accordingly it will do mapping and it will be able to publish. So the store procedure will have to create that data set. So in this, before processing it, what we will do is, even here we have two approaches. One will be the creation of a temporary table, and the other one is a permanent table. For this specific interface, we are creating it a temporary table. Why we create temporary table and why we moved on to permanent table is for high volume bots. Now we are preferred to use the permanent table. For low volume bots, they have asked us to use the temporary table. What we will do this in temporary table is, we will just select the columns whatever available here. If you read the query, you can understand. So you're just creating a temporary table called current warehouse, and you are just selecting the rows from the control table. So here, if you see in the next line, you're inserting the records, how much ever this is the batch count. Assume for this particular bot, I think it is 200. I'm not sure, 200 or 100. So those many number of records, even though you have 1,000 records in your control table, only the 200 records will be picked here because you have given the value as 200. Only that many to be processed in the first batch. So you will be inserting into your control table, you will be inserting it into the temporary table, that records, and this is only for your processing. When you create the raw data set out of it, you are going to delete this table in case of temporary table, and if it is a permanent table, you are just going to truncate that. So that is what that part is covered here. And in this part, as you can see, some regular expression, this replay function and all. What we have, why we introduced this regular expression and what we are doing here is, initially we were getting some special characters, say ampersand, some control characters like that. That was not able to, and IMQ was not able to handle that. So what we do is, only for the columns which are having character as the data type, because only in that we'll be getting special characters. So say I will go and check this table. WHF is an alias name for one table name. So I'll check if this table column value is char. So if it is a character data type, I will just put this. This is I'm just giving, if it is any control character, then replace it with a space, so that there will not be an exception thrown when it comes to MQ, and there will not be any issue in processing it. So that is why we are using this regular expression, where we are replacing these control characters with the space, and then we are sending it. So this is what happens in extract store procedures. And finally, once you have processed it, you are updating the control table value from X to P. Remember, while this process is happening, if you go and check, if it is a huge number of records, you can see the value will be still X. If it is only 1 or 2, in a fraction of a second, it will get changed to P. So when there are huge number of records getting processed, if you go and see the control table where it was P when I showed you, that it will be of value X. And once this entire process gets completed, sorry. Yeah. Okay. So here, once that XML is generated out of all these columns, finally we are updating the viewer control table to P. Here, if you can see, it is written, update this control table, set process indicator is equal to P, wherever you find process indicator equals X. This transaction ID is one more thing. Let me tell you that also. See here, if you see, there is a column called transaction ID. What this will have its role is, this is to track the messages. Say if you are having these many records getting triggered, and you wanted to know finally, say you are processing 10,000 records, and if the consumer says this particular column 24 is missing. So you wanted to find that record. So what value will be given here is initially whenever a fresh record is inserted into control table, this transaction ID column will be null. What the input for this will be from your Java batch. That Java batch will be giving here, it will be putting a package name. A package name, I mean this package extract warehouse, that package name underscore timestamp and which batch it is. If you have for a set of records, you may have a number of batches. So that batch number will be getting appended here. So if you can see the, let me show you now, all these records are null. There will be some records where the value, yeah. If you see here the package name, the timestamp, and which batch number it got executed, this will be here. And the same, this same value will also be extracted when you create your XML. In that row set, you can see after it gets generated, you can see the same value in that. That particular value, we are storing it in our audit table. So while tracking, for every single record, say here, if you can see for this 5502 facility, I'm getting output for that. So for that input audit, it will have the value as this, the same value. So you can go, obviously, you can, if there are any issues, you can go and check with this, if they say for this particular record, they didn't get any, they didn't get the output record from EDIS, you can go and search if with this transaction ID in the message log table, so that you can, from that you can find that if the record is really processed from EDIS or if there been any exception. Even in exception, the same transaction ID column is captured, so that for our further, if any issues reported or if we are checking anything, we'll be able to, go back and check that. This is what happens in extract stored procedure, and in this extract stored procedure, we are calling one more stored procedure where we will drop this table, temporary table. So for every set of run, we will create a new temporary table. So from there, this stored procedure gets called, and in the stored procedure, we are just truncating the temporary table and we are just dropping it. And in stored procedure, there is also one more block of code where in case of exception, it's kind of exit handler. In case of any exception, we don't want to just leave that record as such X or P. So we need some unique identifier for it. So what we do is in case of any exception, the cursor comes here and that particular record, the process indicator will update to F. Here you can see it is given F. And like here how a new record will be N, the processing record will be X, and the process record will be, say, if there are any kind of exception. It might be of anything. If any issues are there in your, any syntax error are there is there in your stored procedure, then that record will be marked as F, so that you can find that there was an exception thrown for this particular record, and you can go back and do your analysis why the exception was thrown. So this is one example of the bot where insert source procedure will come into picture. Let me show you another bot where we don't create this temporary table. If any doubts are here in this. Okay. Okay, this is a bot where we don't have the insert store procedure, because in this bot, every records will be loaded into the control table by OGG. So we need not create a separate insert store procedure for it. Only we will have 3 store procedure. One will be my update store procedure, which will change all the end records to X. That will be the first store procedure. And the second store procedure, the same as earlier. It depends on the bot, the SQL query may be varying depending on the bot. So that will be the part here. Here, if you see the last bot for warehouse master, we were creating it as a temporary variable. Temporary table. The reason why we made it a permanent table here is this bot is where we'll get huge number of records. Since the volume is high, the data mapper suggested to have a permanent table for it, so that records will be processed from your that will be required to process for this. Same thing like that. Whatever records are getting processed from X, you will change that to P here. And in case of any exception, same thing, you will be updating it into F. And the final thing is, unlike the previous one, here we are not going to drop because it is a permanent table. You will just truncate the records for the before moving into the next set of records. So no drop comes here, only the truncate part. So these are the two kinds of stored procedure. Stored procedure and my control table and viewer process control table. All these will be in the schema RDS control, whereas your source table will be in RDS source sims. That is for sims. Whenever the source is sims, you will find that schema, but it depends on the source. The name may be varying. Viewer process control table. Yeah, this is what I was telling why we use it during our insert stored procedure. See, if you can see for every single bot, there is one entry. See, for inventory balance, it is 11 Jan. So whenever, see, this is a old record. So whenever you wanted to try or something, you can make it as a recent date. You don't want to pull 1 year old records. That is not required. So you can change it to a recent date and whatever records from which date you wanted to pick for your understanding, you can change the date and then you can do it accordingly. So whenever my insert stored procedure runs, after 15 minutes, this table will be, that value will be updated to the current timestamp which you are storing. So that if, say, for this retail customer LDAP source, the run is 251. So the next run will be after 15 minutes. So every 15 minutes, this table will be getting updated. And that updating process, we have ESP jobs for it, and that ESP, that automatic triggering will be done by ESP. We will have in dev environment, we will not be creating any scheduling jobs because dev environment is for us. In case of any QA, the project QA team, if they are gonna test, they wanted to check all these, then they can obviously go and check in QA, because automatically every 15 minutes you can see. Now, since it is, I'm showing example for you in dev environment, most are the old dates. So in QA, you can see the updated records. So since we have an automatic scheduler running for it. So this is how the DB part for CDC interface. Any questions? Okay. Pratyasha. Hello. Hello. Pratyasha. Can you hear me? Yeah. Can you open what is that TMA, and we can just stop any flow and we can show them how it gets figured. That can you do, because I feel the curve very slow.
Yeah, no problem. Let me just do that for you.
Okay, thank you.
Shaila, which flow do you want to show them? Have you, do you have a flow in mind? Hello, Shaila, can you hear me?
Yeah, Pratyasha. You just go ahead showing them how this record gets triggered, because when I do na, it is very slow, I feel.
Oh, okay, okay. Let me just a moment. Huh?
Yeah.
Okay, so I'm just going to trigger a few records so that you can see how this particular thing works in depth. This particular portal that you're seeing on your screen is TI, where all the input queues that are configured to our various publisher flows, they are visible here. So if I go under all queues, so all the queues whichever server they reside on, they are all visible here. Since I've put a filter, so that's why the queues that satisfy this filter only are visible. So what I'm going to do is I'm just going to go for a bot that I recently had triggered. So I think that should work for you all. Okay. These are the queues. Okay. I'm going to go and stop the publisher flows so that you can also have a look at how the output that comes from the stored procedure triggering appears like. This particular URL that you're seeing right now is basically a replica of, you can say, a web replica of the broker where your code gets deployed. So I told you that we have two brokers in dev environment. One is this AA7 and the other is AA85. So both the brokers have all our code present here as a replica. Basically, these two brokers are replica of each other. We just have two brokers so that if one of them goes down, we have a backup where our code is also running. So whenever we do the deployment in dev, we do the deployment of our code on both these brokers. So I'm going to go and just stop the flow that is listening to the queue for which I'm going to trigger the data so that I can show you the data as well, like what it looks like. So this is the flow that is listening to the queue that I'm intending to show you the data on. So once I stop the flows, okay, on the other broker it's already stopped. So when these flows are stopped, you can see like the queues that I am intending to show you the message on are okay, this was the one. The one of the flows you just saw was already stopped. The other was listening. So if now I refresh this, I think the other count would also, the readers count will also become 0. Readers count becoming 0, as I've already explained earlier, it means that your flow is not being listened to by any of the applications. So now what's happening is these are the queue manager names here that you see alongside the queue name. These are the queue managers. So since we have two separate brokers, we also have two separate queue managers corresponding to each of the brokers, so that there is one queue corresponding to the flow that is present on each broker. So that is, since we have two brokers and hence two copies of the flow that we have deployed, so we are also having two queues here, one on each queue manager. So I'm just going to show you a certain record which I'll trigger. Okay, so the intended table here in this case, I'm going to trigger the workflow forecast interface, which was developed earlier. So in order to be able to, do so, I'm going to just update a few records. So as it has been already explained by Shahila, that whenever we have to, trigger new records, that new records come into the table in the form of process indicator N. So when I'm doing the manual testing, when I don't have the golden gate available to me, which will be giving me new records every time, I'm just going to manually create a new record by updating the process indicator for this particular table. So if I update the process indicator to N, what will happen is, say just for 3 rows, because I just want to show you a sample. So what's happening is, I have updated the process indicator for 3 of the rows as N. So what's going to happen is that those 3 records are going to appear as new records for my Java batch, which is going to help in the triggering of the messages for the stored procedure. So basically, we are not running the stored procedure manually. We are using a process of we are using a process called Java batches, and we are triggering them so that they can automate the process of getting the messages transformed from N to P by triggering the stored procedure, and then that transformation output which occurs from the stored procedure that goes onto the queue, and from that queue your message is picked up by the publisher flow. Once I start the publisher flow, when it's running on its own accord, the flows are already started, so the message gets picked up automatically from the queues, and then the processing occurs further in the publisher flow. So I have updated 3 rows. So if I check the BO control table, there will be 3 records present in N state. There are 3 records which are with N status. So these 3 records are going to act as new records for me. Okay. So I'm going to go to 50, where I'm going to show you how we trigger these stored procedures to run automatically. Forgotten the name of this service. So once you get your access, you will also get the access to the Unix server, where I am going to run the commands. So since we are going to do the execution in dev, so I'm going to log into the dev server to trigger the Java batch for it. So when I want to trigger the workload forecast stored procedure, I have already created a property file which has all the required data, like the name of the stored procedure which needs to be triggered, and the number of records that need to be converted from, that need to get processed in one batch, like how many records will become P in a single batch. That count has also been identified there. And also the queue, which is going to act as the destination queue for the stored procedure, that has also been put there. So those things will be covering in the subsequent sessions, but we have already put them in a property file, which is present on a location. So now when I have to trigger, so I am just going to sorry, I have to go to the folder where the stored procedure triggering Java batch is present. Are you something wrong here? Okay, all right. So inside the bin folder, we have that Java batch, which triggers the stored procedure to run automatically. So I am going to call the stored procedure along with putting the property file, relevant property file name, so that only that stored procedure is triggered, which I want to trigger, and not all of them get triggered. So first I'm going to write the command to mention the name of the stored procedure, the Java batch which is going to run the stored procedure. And now I'll put the name of the properties file, which is going to trigger the specific stored procedure that I want to get triggered. This was the one. To check the name of the properties file. So this is what happens when we have had a lot of runs. So sometimes we also forget the name of the stored procedure because I ran it long back. So now I have to go and check the name of the properties file. But when you're in the flow of development, you usually, when you've created the properties file very recently, you remember these things. So I have put the name of the Java batch which is going to trigger the stored procedure, and I've put the name of the properties file which is going to help in the triggering. Okay. So when I press enter, so this is started to, execute the records, and when the status completed comes here, so if I go and check these records and I refresh it, so those process indicators should turn to P if there is no problem. Okay, it did not. Okay, it did. So the records have got processed. Let me just cross verify if there is any record present with status N. Okay, they haven't been processed. Still, am I doing something wrong here? I'm not sure why this did not get processed. This control only, right?
Flow.
See, this is the RDS control table where I had the records, and I have used the workload forecast script to run. Not sure. It's showing the status as completed, but it's not, updating the process indicator. Not sure what the issue is here. Okay. Maybe when I updated the process indicator, I did not do a commit. So that records are not getting identified properly. Maybe that could be the issue. Let me try again. Okay, it did. So what issue was that I just ran the update command where I updated the process indicator, but I did not do a commit. So that record was not getting identified as a record which actually exists in the status N. And that is why the stored procedure was getting triggered properly and the process was getting completed without any errors, but no records were getting identified as the status N. So nothing was actually getting processed. But when I ran the commit, so what happened was that the changes that I made in the table, they got, permanently saved. And that is why then they were able to identified by any external entity which is trying to access those records. In this case, it's going to be, it was the stored procedure, so it could identify 3 records as status N. And now, since those records have been processed, if I refresh the view of the queue, there is one message. You see the current queue depth, it has increased to 1. So one message has reached on this particular queue. And it has not been read because the flows which were listening to this queue have been stopped. So I'm just going to show you what kind of a message we are getting here. So it processed 3 rows, and that is why if I pick this message and I'll show you Notepad++, it will be a better picture. So yeah, you can see there are 3 rows because I processed 3 rows, so we got 3 rows here. Okay. And this entire data that you see here, this format has been created inside the stored procedure itself. The extract query that we write there identifies what all records we want from all the tables whose join has been put, and in what nomenclature or with what alias name we want those records to be appeared in the XML output that is coming from the stored procedure. So we got 3 rows because we processed 3 rows and they came inside a row set. And also you can see the transaction ID which is also getting created by the Java batch which is triggering the stored procedure because we don't have any logic of writing the transaction ID in the stored procedure. that logic has been covered in the Java batch, which triggered the stored procedure. So it has also put a transaction ID alongside the message that we ran. So if I, if I want to check whether the messages have been, processed properly, or if there is an exception, I can always go to my audit table and my exception table, and I put a filter on the transaction ID, because the transaction ID is stored in the audit table and exception table. So if I go and do a search in the name of this transaction ID, I will be able to find the, whatever happened to the message, whether it got processed properly. So if that is the case, all the records will only be in the audit. We'll only have audit records. We won't be having any exception records in the exception table. But if some issue has occurred with the processing of these messages, then your this entire thing, this transaction ID is going to appear in the exception table. There will be a record in the exception table if you do a search with the transaction ID filter, putting this particular value. That is the importance of the transaction ID, because it helps us to identify if some record failed or it didn't. So this is the kind of messages that we get. I mean, the generic format that you can see here is not this data, but basically the row set, the transaction ID, and the row. However many records you process, that many rows appear here. So that is something which is generic across all the CDC flows, all the flows which are getting the data from the database. These three things are common there, 3 or 4 things. One is that the record would be an XML format data, because obviously in the stored procedure itself, we converted the extract query output into an XML format data, and then we put that onto the queue. And the fact that it is going to be a row set, and inside that is going to have as many rows as you processed with the process indicator N. And there is going to be the transaction ID here, which is going to be put by the Java batch that helps to trigger the record. So if this particular message is present on the queue manager AA7. So if I start the flow present on the queue manager, the broker AA7, this message will get picked up. If I would have started the one on A85, then this message would not get picked up, because the queue managers are separate here. So if I refresh, this message would not be here anymore, and the message hasn't picked by the publisher flow. So, Shaila, are we intended to show them the publisher flows execution also, or is this what?
Yeah, that we'll see tomorrow.
Okay. So I hope it's clear to everybody how the messages are triggered and how they are fed to the publisher. So that way we have constituted the stored procedure output as the input for publisher flow. I hope, Shaila, you have already told them about the JNDI binding, or are we covering that in the next session?
JNDI binding I didn't pick, because I thought we'll connect that with publisher flow.
Yeah, actually the JNDI binding is something that I should tell them about. Like, most of you might be wondering how the stored procedure data came onto the queue. Like, how is that connectivity being made? So what happens is there is an infra team which does the entire setup on the dev and queue environment and even on prod. So what they do is, whenever we have a stored procedure created and we intend to feed that stored procedure output to a publisher flow whose input is an MQ node. So whatever that MQ node is, it's going to have a queue name, right? So that queue name we need to get created by sending a mail to the infra team, and along with that queue name, we need to give a name of the JNDI binding to the infra team. So infra team has the responsibility of creating that JNDI binding, and what that JNDI binding does is that it creates the connection between the stored procedure and the queue, so that your data, once the Java batch triggers the stored procedure, and the stored procedure eventually processes all the records that are present in the status N, that data gets processed, and the JNDI binding creates a link between the stored procedure and or you can say the Java batch and the queue, so that once the Java batch gets the output returned from the stored procedure, which it has triggered, so that output the Java batch can put onto the queue, the input queue, which is going to act as the input node for your subsequent IB publisher flow. So that JNDI binding constitutes that link, and that JNDI binding is created by the infra team. So you only need to decide the name for it. Once we come up with a nomenclature, we'll be able to explain how JNDI binding naming is done. But the only part that the developer is concerned with is giving the name to the JNDI binding. The creation of the JNDI binding is the job of the infra team. So we just need to understand what the GNDI binding stands for. So it's just supposed to create a link between the stored procedure or the Java batch which is triggering the stored procedure and the MQ which is going to act as the input node for your publisher flow, so that your messages from the Java batch which are returned by the stored procedure can be put onto this particular queue. I think that's all which needed to be explained today. Shaila, is there anything else remaining?
No, Pratyasha, only this is planned for today. Yeah, we are done.
Okay, so if anybody has any questions, they can ask. Until if you have something to say, you can say, otherwise we can wrap up.
I think I'm good as well. So, not for all, one quick thing. So, Anandita, Tarun, Rajesh, Shalab. Yeah. So, anyone of you guys know Unix? I remember someone told me that you guys know Unix.
Yeah, I know some about Unix at
I also know. So, first one, Rajesh. Who was second one?
all.
Shalab. Okay. Okay, let's connect. So, there is small script we have to write down. Okay, to perform two activities, two tasks. Okay. So, we'll talk about that and then we'll do in Komal as well. Okay. Okay, I'll give you guys call in some time. Okay. Okay. Thank you.
Thank you.